Aerospike uses a shared nothing architecture, spreading data across nodes in a cluster. This eliminates single points of failure and allows for easy scaling. The Aerospike Smart Partitions algorithm distributes this data evenly across the cluster, leaving each node with about 1/3 of the data. To understand how this distribution works, we need to look at the namespace. Recall, a namespace is the top-level data container storing records that share a specific storage engine as well as common policies. Inside the database, each namespace is broken into 4096 logical partitions that are then uniformly distributed across the nodes in the cluster. If you want to replicate your data for higher reliability, use the replication factor to define how many copies to store. These replica partitions are then also distributed evenly across the cluster. Generally, you would keep the replication factor less than the number of nodes. Now that we have the namespace divided, how do we know which partition the record is written to or read from? When creating a record, we define a primary key as the unique identifier for that record. This key is the first step in mapping to the correct partition. If the record is stored in a set, a logical grouping of records, then the set name and the key are hashed using the RIPE-MD160 cryptographic hashing algorithm. RIPE-MD160 takes this data and creates a 20-byte digest. The algorithm does so well randomly generating this digest that to brute force generate a collision, you would need over 1.2 septillion operations. That's 24 zeros. From the 20-byte digest, the first 12 bits are used to determine the partition ID where the record is stored. This deterministic process allows Aerospike to consistently map a record to a single partition and lets clients get to the correct node with a single hop.